Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from limits, and here we have a very important problem in which the greatest integer function and the signum function are involved, right? So let us take the problem. So here we are given that limit extends to 0 minus e raised to lambda times greatest integer of x divided by signum of x. This limit is equal to limit extends to 0 positive, and here we have greatest integer of x plus 1 divided by signum of x minus 1, right? So here we are given that these two limits are equal, and we have to find the value of this lambda, right? And here four options are given, and we have to select the correct option, right? So let us start. So in this problem, we are given that this limit is equal to this limit, right? So here we have one limit in the left hand side and one limit in the right hand side, right? And both the limits are given to be equal. So let us first calculate this limit, right? So let us call this limit as L1, and let us call this limit as L2, right? So once we find the value of L1 and L2, we can compare both the sides, and we can easily get the value of lambda, right? So now L1 is given as limit x tends to 0 minus, and here we are given that e raised to lambda times greatest integer of x divided by signum of x, right? So here we have to find the left hand limit of this function, because this negative sign shows that we have to approach uh, x is equal to 0 from the left of x is equal to 0, right? And moreover, here we are given the signum function and greatest integer function. Now let us quickly see the definition of signum function. Now signum of x is defined as plus 1, that is signum of x takes the value plus 1 whenever x is greater than 0, and signum of x is 0 whenever x is equal to 0, and signum of x is minus 1 whenever x is negative, right? So here we'll utilize the definition of signum function. So now here we have x tends to 0 minus, so we have to find the left hand limit. So for this, what we will do, we'll take x is equal to 0 minus h, right? Where h is a positive quantity, and it is very small quantity, right? And it lies between 0 and 1, right? So h is infinitesimally very small, right? And h is positive. So when we take x is equal to 0 minus h, because we have to find the left hand limit of this function when x approaches to 0, right? And here when x tends to 0 minus, then obviously h tends to 0, right? So let us transform this limit in terms of h. So we have limit and h tends to 0, and here we have e raised to lambda times greatest integer of x. So we can now write for x, we can write 0 minus h, that is equal to minus h. So we have minus h here divided by a signum of minus h, right? Okay, now see, here we cannot directly substitute h is equal to 0 in the numerator and in the denominator, right? So what we will do, we'll take help. We'll take help of the definition of greatest integer function and signum function, right? Now see, here h lies between 0 and 1, and here we need to find greatest integer of minus h, right? So for this, what we will do, see, when we have 0, h and 1, and if we multiply this inequality throughout by negative sign, we'll get 0 and the direction of the inequality get reversed. So we have 0 greater than minus h and minus h greater than minus 1. So this is minus 1, and here we have minus h, and here we have 0, right? So minus h lies between minus 1 and 0, while h lies between 0 and 1, and always remember that h is a positive quantity, right? So when minus h lies between minus 1 and 0, then the greatest integer of minus h should be equal to minus 1, right? And here we have signum of minus h, right? Now see, h is positive, right? H is positive, so minus h is the negative, right? So we have signum of some negative quantity, because here we have minus h, right? And for negative quantities, that is x less than 0, signum of x takes the value minus 1. So signum of minus h should be minus 1, right? So now we have the limit h tends to 0 and e raised to lambda times minus 1, because greatest integer of minus h is minus 1 and signum of minus h is minus 1, right? So these two quantities get cancelled, and since this expression is independent of h, so we can omit this limit notation. So we have simply e raised to lambda, right? So the value of L1, which is this limit, is equal to e raised to lambda, right? So viewers, the value of this limit is equal to e raised to lambda. Now let us find out the value of this limit. So now here we have called this limit as L2. So L2 is the limit x tends to 0 positive, and here we have greatest integer of x plus 1 divided by signum of x minus 1, right? Now here this positive sign shows that we have to find the right hand limit of this function when x approaches to 0 from the right of x is equal to 0, right? So we are here at some point which is 0 plus h, right? So here when we find the right hand limit, when x approaches to 0, we put x is equal to 0 plus h, right? And when x tends to 0 positive, h tends to 0, right? So we'll take x is equal to 0 plus h, which is simply h, right? Now we can rewrite this limit in terms of h. So we have L2 as limit x tends to 0 positive gives us h tends to 0, and here we have for x we can now write 0 plus h, which is simply h. So we have h plus 1, and here we have signum of h minus 1, right? Now again we have come across with the greatest integer function and the signum function, right? And here again we cannot directly substitute h is equal to 0 in this limit. So what we will do, we'll find out the separate values of the greatest integer of h plus 1 and the signum of h minus 1, right? So now see, we have h lying between 0 and 1, right? Now if we add throughout 1, then this inequality becomes 0 plus 1. Here we have h plus 1, and here we have 1 plus 1, right? So this is 1, here we have h plus 1, and here we have 2. So this inequality reveals that h plus 1 lies between 1 and 2, and by the definition of greatest integer function, the value of greatest integer of h plus 1 should be equal to 1. So here we have 1, right? And here we have signum of h minus 1. Now see, h minus 1 is always a negative quantity. Why? Because see, h it lies between 0 and 1, and if we subtract 1 throughout, we'll get minus 1 here. Then we have h minus 1, and here we have 1 minus 1. So this is minus 1, this is h minus 1, and this is 0, right? So h minus 1 is greater than minus 1, but it is less than 0. So h minus 1 is a negative quantity. And for negative quantities, that is x less than 0, a signum of x always take the value minus 1. So here we have minus 1 because this quantity is negative, right? So viewers, the value of this limit L2 is now limit h tends to 0, and for this we have 1, and for this we have minus 1, right? And since this term is independent of h, so we can remove this limit notation. So this is 1 over minus 1, that is simply minus 1, right? So the value of this limit is equal to minus 1, right? So we have seen that L1 is e raised to lambda and L2 is minus 1, and L1 is given to be equal to L2. So we have e raised to lambda equal to minus 1, and we have e raised to lambda plus 1 is equal to 0, right? So by this equation, we have obtained this important relation, that is e raised to lambda plus 1 is equal to 0, right? Now, if we see the options, then we can readily see that the correct option is D. Why? Because we know the well-known Euler's relation, that is e raised to I pi plus 1 is equal to 0, where I is the complex number and known as iota, right? So I is nothing but square root of negative 1, right? So we know this well-known relation in complex numbers, that is e raised to I pi plus 1 is equal to 0. And if we compare this relation with this one, then comparing we'll get lambda is equal to I times pi, right? So the correct option is option D, that is iota times pi, right? So the value of lambda is iota times pi. And viewers, from complex numbers, we know that e raised to I theta is given by cos theta plus iota times sine theta, right? And if we replace theta by pi, then e raised to I pi is equal to cos of pi plus I times sine of pi. Now cos pi is equal to minus 1, and sine pi is 0, and this is minus 1 plus 0, that is minus 1. Taking this negative sign to this side, we'll get e raised to I pi plus 1 is equal to 0, right? And we have just seen that when we have L1 is equal to L2, we have e raised to lambda equal to minus 1, that is e raised to lambda plus 1 is equal to 0, and comparing lambda is equal to I times pi, right?